everybody, it's Bruce at Groxio Learning, and I've got the dog on the floor. Today we are talking about Tetris, and more specifically, we're going to start building some shapes. So you'll recall each one of our shapes is represented as a point. So rather than specifying the upper left and the lower right corners, we are just going to specify a single point. And that means that a shape might be points that look like this. So this is our L shape. Remember, each tetromino is 4 blocks, and we're going to render these centered the best that we can on a 4x4 grid, so that the upper left is 1, 1, and the lower right is 4, 4. So we can represent that L shape as a 2, 1, 2, 2, 3, 2, and 3, 3 tuples. So let's take a look at our code base again. So this is our Phoenix LiveView, and recall, let's talk a little bit about the lifecycle. So any request that comes in is going to come into the router. So in our case, this router has a route here that says live, and that's the type of route. That means that we're going to a live view, which is basically an interactive view. It's going to the route game. So this is the URL that our customers will type. And the module that represents this is game live. And this does everything. So essentially what game live is going to do is set up the data for a live view. And remember, the data for our live view is a socket. So we're ignoring the parameters and the session that comes in for now. And we're going to tweak our socket. So initially what we're going to do is set up the live view using a series of reducers here. So we start with a socket, then we feed in a new tetromino, and you can see that this is a reducer. This basically assigns the socket, so there's that special block called assigns, and we're going to put the tetromino variable, which is just a map key in there, and the value for that key is going to be a new random block. So then we're going to dump the points on the page that represent this particular tetromino. Now, right now, we have a pretty dumb representation of the points. So let's look at our user interface. Yeah, it's still been started since the last time that we talked. So there's just this simple point that's starting at the top of the screen and moving down. We haven't implemented any kind of color yet. So this is probably a good place for us to start. So what we're going to do, instead of listing this single point, let's see the code that drops in our single point. What this is actually doing is showing all the points at a location. And remember, this is the Tetris game, so this is where the backend code lives. I'm in tetromino, and there's this function called points. And points right now is just grabbing the point for the location. So what we're going to want to do here is convert each type of tetromino into points. And then when we're done, we'll have the individual Tetris shapes falling. So what's going to happen is right now we're calling points for tetromino. And let's see what that looks like in our live view. So you can see that what we're doing here, no, that's page live. We're actually in game live. But what you can see is when we do a show, that means that everything is moved around and we are now ready to render. And so what we're going to do in this case is we're going to take the tetromino where it stands, and then we're going to dump points, right? So this is the socket assigns tetromino. So all we're doing is grabbing the location, but what we want to do is grab all the different points. So let's look at what this might look like. So probably one great implementation would be to take this L shape and drop this series of points, 2, 1, 2, 2, 3, 2, and 3, 3. That's an L shape. And let's just hard code that into our points and see if we can get that to render. Okay, so now I'm going to cut over to the tetromino. And in this points, here we're just grabbing the location, but instead let's grab a series of points. And I'm going to play a little game here. So I'm going to say 2, 1. I'm going to grab a set of points, and just so it'll help me visualize it, I'm going to list these points exactly in the shape of my tetromino. One of the mentees, Grace McPherson, showed me this technique, and it worked so beautifully because it allowed us to visualize what's happening, what's going on, right? So we start at 2, 1, and that's at an x of 2, so it's shifted over 1, but at the top. And then we move down 1, so that's a y of 2. And then we move down 1, so that's a y of 3. And then we move to the right 1, so that is going to be, we move the x to the right 1, which is 3, and we stay on the same line. So these are really easy to double check because I can go up and down, and I can say that the y value is row 1, row 2, and row 3, and all these are 3. And the x value is everything on this row is a 2, everything in this column is a 2, and everything in this column is a 3. So that's double checked. So that's our point, and let's see what's happening here. Actually, we're breaking, right? So what's happening? We're trying to assign the points in this way, and that's not going to get it done, right? So what we want to do is we want to loop over all the points, and for each point, we want to do the render that way. So let's check out, let's go into our LiveView and see how we can change this up. This is the individual piece, the function responsible for rendering the points. And right now we're grabbing the points out of the assigns like this. Let's grab the points in a more generic way and see if we can't come up with a better way to do this. So what I'm going to do is I'm going to set up a for loop. So this is called a for comprehension, for, and we're going to say point is taken from, and we're going to, actually the point, I can take this apart right here, can I? Well, let's do it this way. It's taken from, right? I don't even need to take this out here because it's in assigns. And since this is a LiveView sigil, I can access assigns.points in this way. And I like that better. And then I'm going to need an end at the end of this. And since this end will not be rendered, I'm not going to have an equal sign. So it's going to be set up just like that. So there's my rectangle. And this is the X. And this is the Y. So one of the things that I could do is I might decide to say, you know what, I think I want this indented one further just so we could see what's going on here. So one of the things that I could do is play the same game that I played last time. I could say X, Y is equal to, and then the point. And that looks like it would work. But we can do a little bit better than that. We can actually do this pattern match. We can drop that in right there. So yeah, so I'm basically going to take the first point out of here, and then I'm going to drop it in, and then I'm going to do all of this work, which is in this case, rendering the rectangle with the first point in it. And so we also need to make sure that this is working okay, right? So here I'm grabbing the top of the points. You know, I don't think that I want to grab that here. I think instead, I want to say, so it's rendering the X and Y. I want to render the location. So let's do the tetro.location. And rather than wrap it like that, let's wrap it like that. So basically, I can still show the location of the tetro. And let's see if we're starting to get some points. So yeah, we are getting points that are rendered exactly like this. And if you'll recall, in our shape, we had a little bit of a gap on the left-hand side, but it was at the top. So we're showing in the right place, and that's pretty exciting. But what we're not doing yet. We're not moving the overall shape that we have to the location that is reflected in our tetromino. So let's go ahead and do that work now. So we're going to actually have to move these points. So when we convert to points, that is done in our tetromino. One of the things that we're going to have to do is move the points right here, right? So we've converted to points, and we're going to need a reducer to move them all. We want to take this whole chunk of points and we want to ship them to the location that's referenced here, right? Or the location that's referenced here. So maybe we'll add 5 to all the points, and maybe we'll add 1 to all the points. So in order to do that, maybe it would be nice to have a reducer for a whole bunch of points. So we don't have a module that has that shape. So let's create one. So I'm going to create a module called points. And remember, what I'm trying to do is maintain a shape so that the first argument and all the functions of the module looks the same. So this is going to be a chunk of points. So that might be a source of confusion, point versus points, but we'll go ahead and watch it. And we want this function called move, right? And so move is going to take an X and a Y and then a bunch of points. No, it's going to be a reducer, right? So we want to take a bunch of points and then an X and a Y. And then we want to do the work in here, right? So I'm going to use a function called enum. So I'm going to go down here and I'm going to say IAX mix. So what I want to show, so we have a couple of unused functions. Don't worry about those yet. We'll clean those up in a little bit. Most of those or actually all of those are in the function that we're writing right now. So we'll get to use them. So I'm going to say that we have a list of points. And let's say, actually, let's use a for comprehension to make those points. So let's say for x taken from, let's just make a square shape. So maybe we have the x is going to run from 2 to 3, and the y is going to run, and the y is taken from 2, 3. Do some work, and I want you to give me x comma y and end. Yeah, okay, so what's happening is this is a for comprehension. So we're going to start with 2 and then start with 2 for y, and then take that combination and generate an xy pair here. And then we're going to advance y, and then we're going to generate the next one. Okay, and then we're done with all the x's. So basically we're going through all the possible combinations of x from 2 to 3 and y to 2 to 3. And look, we get this square tetromino shape. So let's take this and let's say that we want to move this to a location. So we have a tetromino, and the base location, let's say that the default location I think was 5, 1. And let's say we want to move all these. So I'm going to map over these. So map is a function where if I have numbers and I have another function, maybe this function takes something and just adds 1 to it. It's going to do that function. It's going to do this function to everything in the list and build a new function with the results. So this one, 1 plus 1 is 2, 3, and 4. I should get a list of 2, 3, and 4. So let's take something that looks like that, points, and feed that into, instead of this function, this list, feed that into enum.map. And let's feed that a function that will move all the points a bunch in the x direction and a bunch in the y direction. So I'm going to take a function, and that function is going to get a point. So let's call that the tetromino x and the tetromino y. And then I'm going to basically move that tx plus 5 and ty plus 1, right? So 5 and 1 is how far I wanted to move my tetromino, right? So let's see, what did we do? We dropped something here. So enum.map. So I did the points, and then I have this function. Oh yeah, okay. So I didn't return this in the form of a tuple. Okay, yes. So I moved this one. So 2 plus 5 is 7. 2 plus 1 is 3. So all of these, the 2 and the 2, this is moved to 7. This is moved 7. And the 3 and the 3 are also moved 5. That's the x. And all the y's are moved 1. So 2 goes to 3. 3 goes to 4. 2 goes to 3. And 3 goes to 4. So this is the formula that we want to move everything. We want to map over everything. But rather than what we really want, if our x is 5 and the y is 1, that's for our initial location, right? So what we really want is to add this to x and add this to y. Yeah, so it's moving all the points at once, right? So that's cool. So what we're going to do is move all the points right here at once, right? So I'm going to say enum. Actually, I'm going to start with points. So some people aren't going to like this, but I kind of want to keep things pretty simple here. You know what? What I'm going to do is I'm going to build this function. Well, no, let's go ahead and start it this way, and I'll tell you what I'm thinking in a second. So I'm going to map over this. And so remember, we had this function, and we were going to take the tetromino x and the tetromino y, and then we're going to add tx plus x and ty plus y, right? And so that's going to let me move all the individual points that way. So let's recompile them here. And did I not save that? I thought I did. The tetromino that's saved, and the point. Okay, so an anonymous, so I have a syntax error in tetromino 36. So let's see what's broken here. Tetromino 30, oh yeah, so we haven't implemented this. So this uses point, and we also want to use point. So one way to do more than one alias is to build a tuple at the very end with all the things that you want to alias. And so this one, we want to do a points.move, right? And we want to move the points to tetro.location, right? So our initial location, which is 5, 1, we're going to move all the points there. So here's what we're seeing. We're not moving yet because we're not taking advantage of our function everywhere, but we will. So the points so we're basically going to fetch the points for a tetromino by basically fetching all of those and then moving them to the location. And so now what this is going to look like is recompile. So I have this for comprehension that I built initially. So that was points. How did I get points? Points, what's in there? Yeah, so this is the square. This was basically built based on the for comprehension at the very beginning, right? And so I'm going to take those points and I'm going to say Tetris dot points dot move, and then I'm going to give it the points, and I'm going to give it a new block location, right? So Tetris dot tetromino, and I'm going to take a new one, and I'm going to take the location out of there. So basically I should see this initial one moved, or actually let's do this in steps. There's too much going on here. So I'm going to say the change is equal to the Tetris tetromino dot new, right, dot location. So this is basically how much I want to change every single one of those bricks by. So I want to add 5 to all the x's and 1 to all the y's. So now I can say points dot move, and I can give it the points, and I can also give it the change. Okay, so it looks like we haven't done anything in that function yet. So we were working in that direction, right? So we were feeding the move, oh, I haven't recompiled since I built that. Okay, yeah, I compiled one file, so now I can move, yes, and we've moved all these files. But one of the things that I don't like is if you're coming into this code blind, so if you see this and you haven't really been tracking what's been happening, we don't have a name for what's happening there. So let's actually name that concept by building a named function in here. And I'm going to call this def move, right? And so what this is going to do is it's going to take a point and a change, right? And the point, I'm going to maintain this label, right? So this is x, y. So I'm going to label this point, and I'm going to say change x, change y. You know what? I think that this is clear enough. I think it's pretty clear that x, y is a point. And this is really, I guess in physics you call it a vector. And so we're going to return x plus change x and y plus change y. Okay, so now what's happening is when we move a tetromino around and we get the points for it, that's going to start to move, right? And so now we can say, hey, I want you to use, I need the module, right? So I'm alias, right? So Tetris point should no longer use points as a dependency. These should go all in one direction, right? So, but I'm going to use point, and I'm going to say take, this means this and means give me this function. I'm going to say get the point dot move. And how many arguments does that take? Well, let's fill them in. The first one is the point, right? And that's coming from our list. So and one means the first argument. Let's do the long form of this function. It'll be easier to understand, I think. So I'm going to take a function, and each one of those is going to be a point. And I'm going to say point.move, the point, and then the change. Let's call this change. Okay, so here's what's happening. Now we're taking all of the points and we're feeding those into a new function that takes a point and just moves it. And all we've done, the only time that we've saved is future Bruce now can say, hey, what's happening here is we're moving all of the points in the list, and we're using the reducer in the point to do that. So it's really easy for me to think about how I'm making this particular change. And let's see what's happening back here. Okay, so now we have this tetramino, and we want to make sure that I'm grabbing the points from the right place, right? So I have this tetramino, and then I'm getting the points for a tetramino, and I should be getting all of these points, and I should be moving them to the location for this tetramino. And let's see if that's exactly what's happening. So I'm going to go to my LiveView, the game live. And so at some point I need to do a show, right? And so the show is taking the tetramino points, and I'm getting the socket from the tetramino, and that should be moving things down. And so let's, in this area, I'd like to be able to see what's happening here. So I'm going to say, for my debug block here, I'm going to say, give me the tetramino. Right? I'm going to reload this page now. Okay, so this says, oh, the tetramino, it says that's not available. That's because we're saving time. It looks like we're saving less and less time, right? HTML is not implemented for this bit of information, right? Because we needed a string. And so a quick way to turn anything into a string is with an inspect. Okay, so yes, it looks like things are starting near the middle and moving down. Boom, and then I'm starting again. You could see that the first one is down a little bit and it's not in the middle. So let's adjust it a little bit in our template. So a typical piece doesn't start at 5.1 anymore. Where does it start? It starts more at something like, let's see. So since we're adding this location onto every block, so let's see what's going on here. Since we're adding this onto every block, what you're seeing is this gap is not getting filled up, and we're adding 5 is not the middle anymore. So we basically, since we're going to be adding 5 to everything, if this was going to be in the middle, I'd have to back it up 2 squares, and I'd have to move it up 1 square as well. So let's call the starting location maybe a 3, 0. And we might be tweaking this a little bit more as our game evolves, right? So let's restart this. Yeah, so that started at the top, and that's going to go right on down and move down for us. So that's excellent. And so the only thing that we're not doing is, if you look, the shape of this is an L, right? So that wasn't supposed to work that way. But the shape of this one is an S, but we still don't have the right points. So let's work on that next. So this will go really quick. And so what's going to happen is we're going to do a pattern match here. And we're going to say the shape of this one is an L, right? And so we're going to need one of these. So I'm going to build a function called show, right? And the function, well, no, I'm not going to do that. So, yeah, so we're going to need 7 of these, 1 for each of our individual shapes. You know, the thing that's bugging me, I think I do want a show function that does all the manipulations, because it's not just move that we're going to want to do. Eventually, we're going to want to rotate these, and we're going to want to do other things to them as well. So we're going to start with a show function. And the show function is going to take a tetramino, and it's basically going to take the, you know what? These are going to generate points. So maybe this should go in the points factory here, right? So get all these points ready to show. So I'm going to say, and this is going to take points, right? And a tetromino. Oh, let's just call that a tetro, just for grins. Get me used to typing that. So I'm going to say this thing. So we already have all the points. You know, I don't think I like that either. So I am actually going to say we're going to start this with a tetromino, and so this is going to be show. So def show. This is a tetro, and so in this I'm going to take the tetro, I'm going to convert it to points, and then I'm going to call so the problem is that I did not want points to have to know about my tetromino. So that said to me that the right place for this code to live is in the tetromino, right? So I don't need to do the move here anymore, but you'll notice that this won't be moving down anymore. Okay, so what's happening here? So no function clause. Okay, so the shape L, we're doing the pattern match there, so that's breaking as it should. So this is not moving down. This won't move down anymore because we're actually calling points, which doesn't move yet, and not show. So what I'd like to do here is in the game live, this is going to be nice, right? So in show, I'm going to call, rather than, so show is right here. Rather than call points, I'm going to say call tetromino.show. And that's where I'm going to put all the functions that get a particular tetromino ready for me to present. Okay, beautiful. So now all that remains during the whole rest of this video, I know this is going on a little bit long, but for the whole rest of this video, all we're going to do is building out the individual shapes. So now that these functions are tiny and in a good shape, so let's do an O. In an O shape, we had what? 2, 1 and 2, 2. And then basically the same thing on another row. And this is on, this is 2 and 3. And this is all on row 2. And these, let's delete all that. And these will be all on row 3, right? So that's the O shape. And now let's do an S shape. So an S shape is going to be where these are like this, right? So this is a 1, these are 2s, and that's a 3. Yep, so 1s, 2s, 3s. These are all 2s and 3s. And so this is an S shape. Now I'm going to need a Z shape. And so in this one, we're going to move this one over and move this one over like that, right? So these are going to start at 1 and 2, and this is going to be at 3. That's good so far. And what else do we need? We need L's. So we did an L. Did we do an L yet? So yeah, we have an L. So let's grab the L. So I'd like to do the mirror images right next to each other. So these are going to be at 3. But this one is going to be over at 2. So that's 2 spaces, yeah. So these aren't quite far enough. Let's take those over where they should be. Yep. Okay, so that's at 2 and that's at 3, and the rows are 1, 2, 3. We're perfect. So that's L, O, S, and Z. Let's move the mirror images close to each other because it's easier to think about them in that way. Right, S and Z are mirrored, And so we have an O, so we need that long skinny shape, which is an I. And so probably a great place to grab that from is here. So this is an I shape. And actually all I need to do is do a 2, 4 like that. And so that's the I. And so I have an O, and all that's left is what? The T shape. So I have the I, T, O, and then the L, J, and S, Z. Yeah. So this is going to be a T. And we're going to start this on these on rows 1. So, and this will be 1, 1. This one will be a 2, and that'll be a 3. Actually, these need to be on 2s, don't they? Because we want to center them best we can so that they'll be prettier when we rotate them. And then I need a 2, 3 like that. And so 1s, 2s, and 3s, and then these are all row 2 and row 3. So that looks good to me. Let's see if we're looking better here. So no matching clause, unexpected token, tetromino 75. So 75, what happened here? So we have this point shape. Oh, yep. Okay, there's an I. That's looking promising. This is exciting. So we're already moving things very quickly. And now we've got the box. And it wasn't at the top because we had that little bit of padding, but that's okay. And what else is going to come out of here? Yeah, there's another box or an O shape. So you can see that this is an O and it's shaped exactly as we expected it to be. And this is a T shape. Yeah. Okay, so this is working. So the next piece of our project is going to be not to move things around. We have all the different shapes. Now we can start to move them left and right. So that's what we'll do in the next video. So this has gone on too long. Sorry about that, but I hope you learned a lot as we went. So for Bruce and the dog on the floor, this is Groxio Learning, and we'll be back with more Tetris in just a little bit.